Welcome. In this video, we're diving into HTML server-sent events, also known as SSE. Server-sent events allow real-time updates from a server to a client without the need for continuous polling. Let's explore how this technology can enhance your web applications. So, what exactly are server-sent events? Firstly, it's a one-way communication channel going from the server to the client. The server automatically pushes updates to the client, meaning the client doesn't have to constantly ask for new information. It uses a standard HTTP connection, making it compatible with most network setups. For many applications, SSE is a simpler alternative to WebSockets. Finally, it uses a native browser application programming interface with the event source interface. Let's break down how server-sent events work step by step. First, the client establishes an HTTP connection with the server using the event source application programming interface. Next, the server responds by setting the content type to text/event stream. This tells the client that the server will be sending a stream of events. The server then keeps the connection open and sends events as data. Finally, the client listens for these events and processes the data accordingly. As an example, the server sends events in a specific format, like event, update, followed by data, with a JSON payload and an optional ID. Simple messages can also be sent without an event type. Now, let's look at how to implement server-sent events on the client side using JavaScript. First, create an event source connection by instantiating a new event source object with the server's event endpoint as its argument. To listen for all messages, attach an onMessage event listener to the event source. Within this listener, you can parse the event data, typically as JSON, and handle it accordingly. You can also listen for specific event types using the addEventListener method. Specify the event name, such as update, and provide a callback function to handle the data. Key features of Event Source API include built-in support in modern browsers, automatic reconnection if the connection is lost, event-based model for handling different message types, simple error handling with on or callback, and the ability to specify last event ID for resuming streams. Now let's dive into a server-side implementation using Node.js and Express.js. First, create an Express application. Define a route, such as /events, that the client will connect to. Inside this route, set the necessary headers for server-sent events. Setting content type to text/event stream, cache control to no cache, and connection to keep alive are important. To send a message to the client, use res.write to format your data as an event, specifying the event type and data payload. Remember that the server must set the correct headers and format the response with event, data, and empty line delimiters. Let's discuss the event format for server-sent events. Each event consists of several fields. The event field is optional and defines the event type for filtering. The data field is required and contains the message payload. Multiple data fields are joined with new lines. The ID field is also optional and is used for tracking and resuming connections. Finally, the retry field, which is optional, specifies the reconnection time in milliseconds. Let's look at a practical example of using server-sent events. Imagine you're building a real-time dashboard. On the client side, you connect to the server-sent events endpoint using event source. You then listen for specific events like stock update. When a stock update event is received, you parse the JSON data and call a function like update stock display to update the dashboard. Similarly, you can listen for news alert events and call a function like show news alert to display news alerts. Server-sent events have many practical use cases. They are used in real-time dashboards such as stock tickers, analytics dashboards, and monitoring systems. Chat applications also utilize them for receiving new messages, typing indicators, and online status updates. SSEs are great for delivering real-time alerts, notifications, and system messages to users. In addition, they are used in location tracking for updating positions of vehicles, delivery status, or other moving objects on maps. Showing progress of long-running operations like file uploads or data processing is another great use case. Finally, they can be used to display sports scores, news feeds, and social media timelines with live updates. Let's consider the advantages and limitations of using server-sent events. Some advantages are the simplicity of implementation with native browser support, and the ability to work through firewalls and proxies using standard HTTP. Additionally, automatic reconnection is built in, making it efficient for server-to-client updates without needing additional libraries or frameworks, and lower overhead compared to WebSockets. However, it also has limitations. It is a one-way communication channel only from the server to the client, and is limited to a maximum of 6 connections per browser per domain. There is no binary data support as it is text only. Internet Explorer and older Edge browsers require a polyfill. Also, SSE is less suitable for high-frequency updates, and you can't close connection from server side. SSE is ideal for applications that need real-time updates from server to client, while WebSockets are better for bidirectional communication with high message frequency. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.